welcome to Valve Central with me, the ugliest thing in the world. Okay, enough of that. Remember this Valve Amplifier, work in progress Valve Amplifier from my previous video? Well, I thought it was about time I started building the rest of it. I know it doesn't look much different from last time you saw it, but if you look right here, I've added a cathode resistor, and I've also put a capacitor across it. Talk about that later on. Change this transformer because it's just a little bit more suitable. It's still not quite right, but it's about the closest thing that I've got to the right kind of transformer for this thing. And I've also put a cathode resistor, grid resistor, right there. And like you heard before, it works absolutely great. So anyway, in this video, I'm going to make a preamplifier. Still going to use these ones right here because I just like the way they look. And they're easy to set up because they're triodes. And excuse all the cans on my oscilloscope, I haven't really had time to clean up yet. Now I was going to use these like you saw in the previous video, but unfortunately I just cannot get smooth enough DC on the filament to make these work good. So yep, no matter what I tried, I've just still got so much hum through this that's just unusable. This thing, however, makes absolutely no noise whatsoever. As a matter of fact, I connected headphones up to here to listen to it through headphones last night. Put the headphones on, thought I might hear a little bit of hum or a little bit of hiss or something, and I heard absolutely nothing. I started playing a tape through this, and it practically blew my ears off. So, yeah, I've got to be careful with that next time. Anyway, before I go on, I'm just going to go into a little bit of Valve Theory 101, just to share what I've learned. Now, bear in mind I've only just learned about this stuff by experimenting and videos on YouTube, but I'm pretty confident enough to give you a little bit of explaining about our best way to bias tubes and things like that, or valves. I know I use valves and tubes interchangeably, but, you know, it's the same thing. So here is a little bit about valve amplifiers. So here we have a circuit of a very basic audio amplifier using a valve. I'll try to explain things as best as I can here. It has everything needed to work. On the input side there is a capacitor to prevent DC getting into or out of the circuit. The load resistor and valve, which are the actual parts responsible for the amplifying. And on the output there is another capacitor and a resistor to prevent DC high voltage getting out of the circuit. And if we take a look at the transistorized version, you can see that the circuit is practically identical. Anyway, this circuit can amplify a small audio signal and it will work quite well, but for larger signals this is completely useless. And why? One word: bias. And what is bias, you ask? Well, it's a small voltage offset applied to the base of a transistor or the grid of a valve, and as long as the voltage is just right, not too low or not too high, it can amplify a stronger audio signal with no distortion. In this transistor amplifier, to bias it, all we need to do is add a resistor here, and it will raise the voltage at the base just enough and the circuit will amplify. Valves, on the other hand, need negative bias, or in other words, the voltage at the grid must be lower than the voltage at the cathode in order for the valve to amplify. And you can clearly see in this circuit it has no parts to apply the bias voltage. But the valve, when it's warmed up, it will naturally put about -1 volt on its grid, and that's just fine for small signals. But if we want to amplify larger signals, we are going to need more bias. So how can we go about solving this? Well, one way is to put a battery in series with a resistor between the cathode and the grid. The battery will supply the voltage necessary to bias the grid, and the resistor will make sure that an audio signal can get through relatively uninhibited. And this is how it was done in some of the old radios. But there is still a better way to do this. So, here is the best way to do it. If we put a small resistor, let's say 470 ohms, between the cathode and the ground, it will actually raise the voltage at the cathode, and let's just say in this case it raises the cathode's voltage to 6 volts. We still need to do something to the grid though, because right now it will still be about a volt below what the cathode is, and in this case about 5 volts, So if we put a resistor between 100k or 500k between the grid and the ground, the grid voltage will be at 0 volts, but the grid voltage relative to the cathode will be around negative 6 volts. And this is because the cathode is 6 volts higher than the grid, so this means we have more bias, and we can amplify a much larger signal. But we're not done quite yet. There is one small problem this circuit has. That is, we lose some gain. But we can fix that by adding a capacitor here. The capacitor doesn't need to be of a high voltage one, and the resistor doesn't need to be a high wattage one, since they will only see a few volts across them. About a half watt will do for the resistor. You can even use a variable resistor here to find the ideal resistance. But like I was saying, we can also get away with using a capacitor with a voltage rating as low as 16 volts. That will be just fine. We won't get anything releasing the magic smoke or exploding in our faces, so there's very little reason to worry. Anyway, here you can see a practical amplifier circuit that I've designed, except it's connected to a speaker through a transformer. The control grid is connected exactly the same way, but because I'm using a pentode valve, I've added this 10k resistor here to supply the screen grid. The capacitor from the screen grid to ground just adds a little bit of stability, and I've connected the suppressor grid to the cathode. So let's see this circuit in real life and take some voltage readings. Okay, well I hope I didn't bore you too much with that stuff, but I just wanted to share that. Anyway, like I said, sure, if you look in any kind of valve circuit, that's the kind of setup that you're going to see. Anyway, like I said, I'm going to take some measurements. Firstly, we're going to have a look. We have across the capacitor and resistor here. Well, they're connected in parallel anyway, so I just connect across the resistor, hopefully without burning myself or electrocuting myself. Hope my hands aren't getting in the way like they always do. We have about 6.6 volts there on the cathode resistor. Okay, now we're going to measure the voltage between the cathode and the grid. I know this looks like where the plate would be connected, but in this valve, that's where the grid's connected. I don't know, it's weird, but I'll put one wire on the cathode, one wire on the grid. Doesn't really like that, it's crackling a bit. And we've got about 6.4 volts there. And I know some of you are interested in what the power supply is and how much plate voltage there is and what's going into grid 2, so we'll just go and measure that right now. Right, I've got one lead on the common. Got the common lead on one wire there. Okay. First of all, we'll just measure what the grid voltage is relative to the ground, and it should be around 0 volts. Okay, we've got about 3 millivolts there. Of course, I can measure the cathode voltage. I'll have to put my meter up a little bit. Cathode voltage, well, you already know what that is. It's about 6.5 volts. Voltage going to the screen grid through this resistor is about 302 volts. Power supply voltage is about 330 volts. And on the plate we have about 323, which is a bit too high for this tube, but I'm going to take care of that later on anyway. Okay, I'm ready to start work on the preamp. But first of all, let's go over all these little bits and pieces that we've got on the bench here. Pay no attention to these things over here, they're not in the circuit. Power comes into this transformer here, which has multiple input taps, so I can use this as an auto transformer. So I've got the 200 volt tap going into this one. So this one gets 200 volts now instead of 240. So it won't get so much B plus voltage and run the tubes at a higher voltage than they should be. Also, the low voltage outputs of this transformer. I can use this to power the Valve's grids. The output of this transformer gets rectified by this microwave oven diode here and filtered by this capacitor. I've got this transformer here which I'm using as a choke. That finally goes into this capacitor and get a nice smooth DC out there. Let's go over what I've got here. So here are the components for the preamp part of the amplifier. Here is our active component, triode valve. This is going to be the volume control. Got a plate resistor, our cathode resistor, cathode capacitor, input capacitor, and output capacitor. So I'm going to wire this up. This is going to be wired exactly like you saw in that circuit diagram earlier, so I don't need to put up a schematic of how this is all going to be wired up. Okay, we've got the circuit wired up. Haven't got anything connected to the output or the input yet, but this is going to be the first stage in my Valve amplifier. And this valve hasn't been powered up since it was tested in the factory back in 1943, because that's the date I found on the box that it was in. So that's how I know what year it's from. So I'm going to plug this in now. See if it works. Okay, smoke test. Good, nothing exploded or caught on fire. That's a world record for me. I can just about make out that glowing. Yeah, I might be able to see it with the lights turned down. Alright, so we're going to take a few voltage readings. Make sure everything is performing the way it should be. Then I'm going to try applying an audio signal into this and we'll see what it does. First I'm going to test the voltage at the base resistor. Base resistor? What am I talking about? This is a valve, not a transistor. Like I said, I'm going to test the voltage across the cathode resistor, which is right here. Just trying to get in, not to burn myself or electrocute myself. We have nothing. Okay, that's kind of odd. Well, I got my meter in the right. And we should have more than that. Well, I don't know why we don't have anything across the cathode resistor. We should have something there. Okay, we've got about 2.5 millivolts. So what do we have between the cathode and the grid? Okay, this goes to the grid, this goes to the cathode. Let's see what we got. A lot more. Let me put this on a higher setting. We've got about 1.10 volts there, so I don't know what's going on. Okay, let's see what voltage we got at the plate. Here we have 0.99 volts. That doesn't seem right. Okay, something is seriously screwed up here, and I don't know what the hell's going on. Well, what output voltage is this doing? Okay, I don't think my power supply is working. I don't know if there's some problem with the connections in these two transformers. I don't know if maybe this has gone open somehow, or quite what is going on really. I was jiggling these wires about, making them a bit neater, so maybe that's the problem. I'm gonna go through this, all of this, one by one, trying to find out what the problem is. I think the first thing I'm going to do is take a magnet to the transformers, make sure they're working. Yep, that one is on. And this one appears to be on, because I can feel the magnet vibrating. So somewhere along the circuit we are just not getting power. Needs more power. Right, let's check the voltage coming out of the first capacitor. We have about 309 volts. Let's check the voltage we got here. I think I found the problem. I think there's a bad connection right here. Well, there's your problem. See that? That's the little wire, and it's come right off that. So that's why it wasn't working. But I can rebuild it. I can make it work again. I have repaired the choke now. And I have powered this circuit up. And it's doing something rather surprising. Let me just plug it in. And you'll see what I mean. I've got the meter measuring the voltage between the plate and the ground at the moment. So see, I plug it in, the voltage starts climbing, but when that tube starts warming up, let's see, it's starting to drop. And do you know why I think that is? It's only about 22 volts. I don't know why, but for some reason this meter looks really glary on the thing. If I can just get that round so you can see that. There we go. So I've only got about 21 volts at the plate. Yet we're getting about 300 volts going into the circuit, so I'm not going to touch anything, so I don't want to zap myself. But what I am going to do is I'm going to replace the cathode resistor right here. Oh, one thing I forgot to mention. When I was showing the components earlier, I forgot to put the grid resistor in. Well, it's in the circuit right there, between the grid and the ground. So what I'm going to do is I'm going to take this resistor out and replace it with this variable resistor. Then I can control how much resistance there is at the cathode. Now I've got a variable resistor here between the cathode and the ground, and I can find the ideal resistance by twiddling this variable resistor. And when I find the ideal resistance, I'll whack in the closest resistor that I can find, and we'll see what we get. So let's plug this in again, and let's see what else we fail at. Okay, plate voltage is spiked at about 252 volts. Okay, it's going down. We've got about 51 volts. I'm just going to let that warm up so we can do this more accurately. Okay, it seems to be stabilizing at about 50 volts. So when I adjust this, I can get the ideal resistance. Here is the final design of the preamp. I made a little change to this, because this variable resistor, which I'm going to use as the volume control, was connected between the plate and the ground, and it still is, but I've moved this capacitor so it's now in between the plate and the variable resistor, so just think it's a little better that way. Still got the same 470k resistor for the grid, and for the cathode resistor I've used a 2.2k because, well, I was tuning this, it seemed to be best around that, so that gave me about 50 volts at the grid, so that's what I've decided to use. So let's just take some voltage measurements, then we'll connect this to something and see how good it actually works. So let's just take a look at the voltage between the cathode and the ground. Alright, there we go, it's about 5.6 volts, and I got my leads mixed up the wrong way around. I remember to use these wires because the original leads got damaged. But anyway, it's the ground, here's the cathode, we got about 5.6 volts. So that means we're going to have the same voltage at the grid, but negative of course. And the plate voltage, let's just measure that. I'll just come around here, try to keep out of the way. Of course I've got to put my meter up a bit. Yeah, we've got about 48 volts there. I think that's going to be good enough. Okay, well, here we are with the Valve Preamplifier hooked up. And this music you can hear in the background is playing on my computer over there. Well, I can't really see it, but I've got the output of that hooked up to the grid of this valve, and that is going into this tape deck here, just directly through that and into my amplifier. And as you can hear, it's working pretty good. Anyway, later on what I'm going to do is I'm going to make a recording directly from this valve. I've got this ready to record. As if you remember, this is connected to the valve's output, so I'm going to play the computer through that, record it onto this tape, and then transfer that tape onto the video. So we'll be hearing pretty much a direct output from this valve. And here we are, a big mess of wires. Actually, this is my finished prototype for my Valve Amplifier, and I must say I think it works quite well, although it does do something a bit weird which I will explain in just a few minutes. But it might also interest you to know that the sound you're hearing, my voice right now, is actually going through this amplifier, and I'm not actually saying anything in this video right now. I'm letting the amplifier speak for itself. Or rather, speak. Well, you know what I mean. Okay, so there's my Valve Amplifier in action. And anyway, yes, like I said, I think it's, I'm going to call this a success. Now, on to that weird thing I was talking about just a minute ago. The weird thing is, right, I've got it connected up to my reel-to-reel, which is supplying the audio signal. Not sure how well that's coming over on the video, but if I switch the reel-to-reel to monitor from the tape, as you can see, the level meters shoot up, even though it's not playing anything. And I get a very faint hum out of the speaker. However, it does still play.
Died, the life force is leaving us. Exploded, gone, the feet are cold.
That's kind of depressing, isn't it? Anyway, I think what's going on here is we got some kind of high frequency oscillation going on here, and I checked that with the scope. And it's about oscillating at about 17 kilohertz, which it should be doing. And I think what's going on is the output from this transformer is just kind of magnetically interfering with the preamp on this tape recorder, and that's just going round and round and round in an endless loop, and that's why we can see the meters acting strangely. If I take this wire here, which is connected to ground, and stick this on the transformer, looks like I get a good connection. That weirdness stops completely. I release it, the meters shoot right back up again, although you can barely see it on the video. Okay, well, that's just about it for this video. Anyway, I'm now going to leave you with the schematic diagram, and then I'm going to go, because I've probably gone on for about 5,000 million years of rabbiting on, so yeah, that's just about it for this video, and until next time, goodbye. Anyway, here is the schematic diagram of my two-stage Valve amplifier that I've made. As you can see, it's not a terrifically complicated circuit, but everything is right here as it is wired up. And I think I just bumped the camera, but never mind. So yeah, if you want to ponder over this, then, or even build the circuit yourself, please feel free to do so. Anyway, that's just about it from me. So until next time, goodbye.